Hi, very warm welcome to this Friday evening. Um, Today, we wanted to shift the time from 6:30 to 7. Inconvenience regretted. So, let us discuss a plus one topic, plus two topic today. Fridays are dedicated for plus two, so that we are going to discuss uh, an insightful topic from plus two, from the area electrostatics. Today, I wanted to give you some valid insights related to the concept of equilibrium in connection with electrostatics. Actually, we learn equilibrium concept in plus one physics, especially starting from the chapter laws of motion. So, what is the concept of equilibrium? Equilibrium, there are two kinds of equilibrium you have learned. One is translational equilibrium. The second one is rotational equilibrium. Translational equilibrium attributes to a situation where the net force acting on some object is zero. Net force is zero. So that literally in that particular object, there might be various forces acting, but the resultant of all those forces will be equal to zero. That is the meaning of equilibrium. In that particular case, I wanted to iterate one of the important misconceptions most of the students have. They think that if one object is at translational equilibrium, that means if the net force acting on those particles is zero, then that object will be at rest. This is a serious misconception, because as per the first law of Newton's first law of motion, every object will continue its state of rest or of uniform motion unless and until it is acted upon by an external unbalanced force. In reverse, we can interpret Newton's first law as if an object is under a state of rest or under uniform motion, we can say that the net force acting on the object is zero. What does it mean? Think about it. Actually, the object either will be at rest or it will be under uniform motion. It will continue its motion with a constant speed along a straight line without any change in its direction. If it is, if there is no forces acting on that particular object. So most of the students have the misconcept that if an object is under equilibrium, it will be at rest. So if you are having such a misconcept, please come out of that and realize this situation. Both are possible. It can either be at rest or be under uniform motion. Both are possible. Okay. Now, we are considering the state of equilibrium in a particular case. Let me share my screen for you for getting better insights. I'm connecting this concept of translational equilibrium yes. Here is the screen. So I wanted to explain this concept of translational equilibrium with the help of electrostatic charges, or a situation where charges are included. So let me explain. See, we are considering 3-point charges in this particular case. Q1, Q2, and Q. Q1 is placed at position A, Q2 is placed at position C, and Q is placed at a position B, which is in between A and B. Now, the distance between Q1 and Q, it is given to be R1, and distance between Q and Q2 is given to be R2. Okay. This is the general situation. Now, we are considering the various possibilities on this particular situation, because we know that charges are of two types. So Q1, Q2 can either be positive or be negative, but there are three charges. So we need to consider all the possibilities. So let us consider one possibility, possibility number one. That is, the two charges at the extreme positions, that is Q1 and Q2, they are like charges and QB an unlike charge. That is the first scenario. Okay. Here in this particular situation itself, we can have two different situations. That means both Q1 and Q2 be positive and QB negative, like this. Or reverse is also possible. Q1 and Q2 can be like charges. That means both Q1 and Q2 can be negative as well. In that case, the Q will be unlike, that is positive. So both these two situations are identical. So we are discussing the concept of equilibrium related to these two situations. Let us look into that. We will check one by one. We are considering first the force acting on the charge Q1 by the other two charges. Okay. So by the principle of superposition, we know that the force acting on a single charge due to a system of other charges, a number of other charges, can be obtained by taking the vector sum of the individual forces. That is what we know clearly. Okay, that is the thumb rule or ground rule in this particular regard. So we need to calculate the force acting on first charge by taking superposition principle into consideration. So what is the force acting on first charge due to the other two charges? First charge means charge Q1 due to minus Q and Q2. So you think about it. I will explain this. See, consider charge Q1. Charge Q1 will be attracted by minus Q charge towards it. Okay, attraction means it is acting towards negative x direction, that is from A to B. The force exerted on Q1 by Q will be towards Q, that is with respect to the figure from A to B, that is towards minus x direction. So that is the first force, and that force, direction of that force we obtained, then whatever the magnitude, we can calculate it using Coulomb's law. That is 1 by 4 pi epsilon 0 into Q1 Q divided by R1 square. And it is acting towards positive x direction from A to B. Okay, that's it. Now, what about the force acting on Q1 due to Q2? Q1 and Q2, if you consider Q1 and Q2, both are like charges. So like charges will repel each other. So obviously, Q2 will repel Q1 along the opposite direction. That is, it will repel along BA. That is the direction of the force. From B to A, that will be the direction of force exerted by Q2 on Q1. And what about the magnitude of that particular force? By the same Coulomb's law, 1 by 4 pi epsilon 0 into Q1 Q2 by R1 plus R2 the whole square, because the distance between Q2 and Q1 is R1 plus R2. So we shall write it like this. That is, see, you consider the first force, it is acting along the positive x direction, along AB. That is force between Q1 and Q. That is given to be the first charge. 1 by 4 pi epsilon 0 into Q1 Q by R1 square. Now, the next force between Q1 and Q2 are acting along negative x direction. That is the negative sign appearing here. I have skipped a single step because first equation we need to write it as 1 by 4 pi epsilon 0 into Q1Q by R1 square minus 1 by 4 pi epsilon 0 into Q1 Q2 by R1 plus R2 the whole square. Okay, so we have taken out the common factors, that is Q1 by 4 pi epsilon 0. Then remaining part we put inside the bracket, which are Q by R1 square minus Q2 by R1 plus R2 the whole square. So this is the way we found the net force acting on charge plus Q1 due to the other two charges, minus Q and Q2. And the same is true for the third case also. If the two charges on the extreme ends are negative and the intermediate charge or the charge at B is positive, the same is applicable. Okay, both are the similar situations or same kind of situations. Now we wanted to force acting on second charge Q2, that is F2. And here also F2, on F2 there are two forces, Y minus Q and plus Q1. Now let us think about it first. Okay, you think about the forces acting on Q2. The first force, it is by Q. Then Q is negative and Q2 is positive. Then what will be the nature of the force? Q2, let me take the laser for your better understanding. Okay, so Q2, it is positive and Q is negative. So Q2 will be the force acting on Q2 by Q. It will be along PB from C to B because Q will attract Q2. So it is along the negative X direction. Now you think about the force acting on Q2 by Q1. Q1 will repel Q2 along BC towards or away from Q1. That is the nature of the force between like charges. They will repel each other. Okay. Now, what about there are two comments came here. Hi. Nice to see you all here. I would like to see you. Now, I didn't notice. Sorry for that. Now, let us consider the force acting on Q2 by Q1. It is along the positive X direction from B to C. Okay. Then what about the force 1 by 4 pi epsilon 0 into Q1, Q2 by R1 plus R2 the whole. Now, what about the force acting on Q2 by Q? That is 1 by 4 pi epsilon 0 into Q into Q2 divided by R2 square, which is along the negative X direction. So here, when we sum both the forces, we will be getting this particular equation. Force acting on charge Q2, F2, that is equal to Q1, Q2, 1 by 4 pi epsilon 0 into Q1, Q2 by R1 plus R2 whole square. That is acting along the positive X direction. That is why it is written first. And the second force, 1 by 4 pi epsilon 0 into Q2Q by R2 square, which is acting along the negative X direction. Okay. Now, we need to consider one more object or one more charge here. That is the middle charge Q. See, on Q, there are forces from by plus Q1 and plus Q2. Q1 and Q2 exerts force on minus Q. Then what about the nature of force acting on charge Q? See, due to Q1 will attract Q towards it. So it is along the negative X direction. Its magnitude is 1 by 4 pi epsilon 0 into Q1Q by R1 square. That is towards negative X direction. Then what about the force acting on Q by plus Q2? It is towards positive X direction. And magnitude is given by 1 by 4 pi epsilon 0 into Q2 divided by R2 square. Okay. So this is that particular. So we got the forces acting on all the three charges. First charge Q1, that is F1, this much. Then force acting on charge Q2, that is F2, which is equal to this much. And force acting on charge Q, which is equal to F, given by this much. Okay. Now, we can consider the case of equilibrium for all these cases. What do you mean by equilibrium? We already discussed that equilibrium means the net force acting on a particular object is zero. In that case, the object will be under translational equilibrium. So, since the force acting on first charge F1 is this much that we calculated in the previous slide, if this force is equal to 0, then the charge Q1 will be under equilibrium. So, what does it mean? F1 is equal to 0 means this quantity cannot be 0. Then the possibility is this quantity should be 0. This quantity should be equal to 0 means this equal to this. You equate the quantity inside the bracket with 0. Then you can take one quantity to the other side of negative equality, so that you will be getting Q by R1 square is equal to Q2 by R1 plus R2 the whole square. What does it mean? It simply means Q by Q2. You cross multiply this particular equation. Q by Q2 equals R1 square by R1 plus R2 the whole square. This is the condition for Q1 to be at equilibrium. So the condition of Q1 or equilibrium condition of Q1 is determined by the charges Q1, Q and Q2, and similarly the distance between them. If Q1, the ratio of Q and Q2 is equal to R1 square by R1 plus R2 the whole square, then Q1 will be at equilibrium, which means Q1 will be either at rest or it will be moving at uniform or constant speed. I hope you got the concept clear. Now it is easy to discuss the equilibrium condition for F2 or second charge Q2. See, this is the equation for net force acting on Q2. Q2 by 4 pi epsilon 0 into Q1 by R1 plus R2 the whole square minus Q by R2 square. Okay. Now, for F2 to be 0, this two quantity must be equal. Then only while subtracting one from the other, you will be getting 0. Okay. So that is the implication. Now, what does it mean? That means Q by Q1. This Q1 can be taken to this side and R2 square to this side. Q by Q1 will be equal to R2 square by R1 plus R2 square, which means the equilibrium condition of Q2 will be determined by these two charges, Q and Q1, and similarly the distance between these two. Okay, that's clear. Now we wanted to look at the charge minus Q as well. You consider that. Now we know that the force acting on Q is given by minus Q by 4 pi epsilon 0 into Q1 by R1 square minus Q2 by R2 square. Or if we are having the freedom to put this negative sign inside the bracket. In that case, the equation will become Q by 4 pi epsilon 0 into Q2 by R2 square minus Q1 by R1 square. Okay. In order to follow the correct order, then I took the negative sign outside. That's it. If you are having the freedom to put the negative sign inside the bracket as well, no issues at all. Now, you think about the situation where this F becomes 0. In order to, for F to be 0, the quantity, only possibility is the quantity inside the bracket must be 0. Because why? This cannot be 0. Q is not equal to 0. 1 by 4 pi epsilon 0 is 9 into 10 raised to 9. It is also not equal to 0. So, in order to get 0 by the product of two numbers or two factors, one of the factors must be 0. So here, this is not equal to 0. That's sure. We clearly know that. So the only possibility is this must be 0. If we want F to be 0. Okay. Then that is the condition we are giving here. Now see this, for F to be 0, this quantity must be 0. If this quantity is 0, what does it mean? These two quantities are equal. Then only by subtracting one from the other, we will be getting 0. Okay. Now Q1 by R1 square equals Q2 by R2 square, which implies Q1 by Q2 is equal to R1 square by R2. This is the condition for Q to be in equilibrium. And these three conditions are true for both the cases. Which are both the cases? If the extreme charges are positive and intermediate charge is negative, or vice versa. That is, extreme charges are negative and the intermediate charge is positive. Okay, both are similar situation. Okay, now we wanted to check the other possibility. See, if you think about a situation where all the three charges are like charges, all the three are either positive or either negative. Let us consider that possibility also. See this. All three charges are positive or all three charges are negative. Then what about this particular situation? We are considering the middle charge first, force acting on charge Q, that is F equals, see here, on Q, two forces are there, one by Q1 and the other by Q2. Q1 will exert a force along the positive x direction. Q1 will repel Q. Similarly, Q2 will repel Q along the opposite direction. Okay, now that is given by, see, Q1 will exert on force on Q on the positive x direction. That is 1 by 4 pi epsilon 0 into Q into Q1 divided by R1 square. Now, Q2 will exert force on Q along the negative x direction, so that equation will be 1 by 4 pi epsilon 0 into Q2 by R2 square with a negative sign. Okay, so taking the common factors outside, we can write Q by 4 pi epsilon 0 into Q1 by R1 square minus Q by R2 square. Now, in this case, if we want Q to be at equilibrium, this is the condition. If Q is in equilibrium, then this force must be 0, which implies the quantity inside the bracket should be equal to 0, as we told earlier. Now, this quantity, if this quantity is 0, then that simply implies that this first quantity and second quantity are absolutely equal. Now, which gives Q1 by Q2 is equal to R1 square by R, as in the previous case itself. Now, you think about the equilibrium conditions of Q1 and Q2. Here, Q1 and Q2 will never be under equilibrium. Why? Here, Q1 will be repelled by Q, that is along negative x direction. Q1 will again be repelled by Q2, again in the negative x direction. Both forces are along the same direction. So, Q1 will never be in equilibrium in this particular case. Okay, in both the cases, in both the cases are similar, because in both the cases, all the three charges are like charges. Okay, now what about Q2? Same here also, because Q is getting repelled by Q and Q1. Q2 is getting repelled by both Q and Q1. Both forces are acting along the positive x direction. So Q2 will be moving or accelerating along the positive x direction, whereas Q1 will get accelerated along the negative x direction, but Q can be under equilibrium. Under equilibrium means it can either be at rest or it can be under uniform motion. So that's about it. Now, I wanted each one of you to think about any other possibilities are here. Is there any other probabilities? We considered two special conditions. One is extreme charges are like charges and intermediate charge is unlike charge. That was the first case we discussed. Now we discussed all the three charges are same. Okay. Now you think about any other possibilities are possible here. Okay. Any other orientations are possible here in this pattern. And you try to solve those situations and arrive the answers. And if you find something interesting, you just comment below. And after practicing the new scenario, if you could find something interesting, you can write as a comment under this video. Now, I thank each one of you for being here for this much of time. And Fridays are dedicated to +2 topics. Once again, I wanted to reiterate this because if you are watching this for the first time, I wanted you to understand the schedule of these live sessions. We are running live every day in a week. Okay, Monday to Saturday, the sessions will be usually at 6:30 p.m. But today, unfortunately, I wanted to postpone the time from 6:30 to 7 p.m. That's what happened today, only for today specifically. But usually it happens at 6:30 p.m. Now, let me share you the schedule of the live sessions. On every Monday and Thursday, I will be discussing some topics related to +1. And every Tuesday and Friday, I will be discussing some topic related to +2. And on Wednesdays and Saturdays are dedicated exclusively for high school topics. Now, one more day, Sunday. All these 6 days, Monday to Saturday, the live will be at 6:30 p.m. But Sunday live will be at 10:30 a.m. IST. And on Sundays, I will be discussing some general topic, which is applicable to anyone, irrespective of the classes. Even it will be general for anybody in connection with physics. Okay, I will be discussing some topic which is connected with physics and also applicable for everyone in our daily life. So, if you find something interesting in this particular session, I would like you to attend my free webinar, which is called Physics Made Easy. Because I know from my experience for the last 20+ years as a physics faculty that most of the students experience struggle, pain, and overwhelming experience while they try to master physics. Especially the fifth is really, really painful when they move from high school to +1 classes. And in my free webinar called Physics Made Easy, I will be detailing all the backstories and realities with the help of valid data and researchers. I will explain the gaps and cracks that exist in our broken education system, especially when it is related to the learning or mastery of physics. And I can help you with an amazing journey with my SGLS framework to master physics. So everything will be discussed in that particular webinar. It will be a 2-hour long session. So register for my free webinar by clicking the link given in the description below. It will be taking you to a landing page. You will get more details of the free webinar from there. You can register from there. It's absolutely free. And block your calendars for my next webinar and be there with full of energy next time to have some valuable insights and to get a solid roadmap for physics mastery. So see you next time. Thank you. Bye-bye.